Welcome to today's tutorial. It's about web scraping with Python. In today's digital world, data is the key to unlocking valuable insights, and much of this data is available on the web. But how do you gather large amounts of data from websites efficiently? This is where Python web scraping comes in. Web scraping, the process of extracting data from websites, has emerged as a powerful technique to gather information from the vast expanse of the internet. In this tutorial, we're going to explore the various Python libraries and modules commonly used for web scraping and delve into why Python 3 is the preferred choice for this task. And these are the main points that summarize the scores. Using imports, Beautiful Soup, and requests, requesting the target web page, reading and decoding, parsing, basically an introduction to web scraping with Python. And this is the website that we will be scraping from. It's an open source from our friends at RealPython. The objective is basically this is a standard web scraping example. The objective is to scrape the word Dionysus from within the website itself. So we're going to have to change this into a markup string and parse it accordingly. And as you can see, this is our Python script. What it does is importing libraries. It imports the requests library for making HTTP requests and the Beautiful Soup class from the BS4 library for parsing HTML. Then it makes a GET request. It sends a GET request to the target website and stores the response in the variable R. Then it prints the status code of the response, typically 200 for success. Then the HTML content of the response is parsed using Beautiful Soup that we imported and stores it in variable soup. So that's a variable we're going to call soup basically. Then we're going to print out the prettified HTML, which is the parsed HTML content for readability and analysis. Now we're going to go into detail into each of these, starting with the all-important URL lib.request in Python, which is a module that lets you send HTTP requests and fetch data from URLs. It's commonly used for basic web scraping tasks or fetching data from APIs. Let's break down the main takeaways from analyzing this web scraping code script. So first, requesting the web page, the code from urlib url.lib.request import URL open and URL equal the HTTP, the domain name we're trying to reach, and page equal URL open parentheses URL. This is the open function in Python, and we're gonna give its value to the variable called page. Description: the code starts by importing the URL open function, like we discussed just now, from the URL lib request module that we imported. This function is used to send an HTTP request to a specified URL. That's why it has in its parameter a URL. Um, in this case, the target URL is olympusrealpython.org, the website we spoke about from real Python to get the word Dionysus. The URL open function uh, fetches the content of this web page, and the result is stored in the page variable. So we created a variable called page, and we store the result of the URL open function in this variable. And we gave this variable a parameter or instance attribute, we can say, within the parentheses outside URL after URL open, the value of the real Python Olympus website. So this one for you guys reading this this line, which is page equal URL open parentheses with letters URL in it. Okay, hope this is clear. Anyway, we are available for one-to-one sessions for delving deeper into all these concepts and doing function by function examples on idle. So the URL open function fetches the content of this web page, and the result is stored in the page variable. This step highlights the fundamental action of a web scraper, which is retrieving the raw HTML content of a web page from a server. Step 2, reading and decoding the HTML. The code for it is HTML page.read open and close parentheses .decode open close parentheses. Inside them is a string with UTF-8. So this is the encoding. Describing this, the page object. This is an object. An object is an instance of class, but this is a top object for later, a subject for later, OOP, object-oriented programming. Very important topic. Applies to Python, to Java, to JavaScript. So this is an application of that. Page, which was the variable, it is an object of a class. So it's an instantiation of a class, which contains the server's response, has a read method. This method reads the entire content of the fetched web page as a sequence of bytes. Since web pages are typically encoded in a specific character encoding, most commonly UTF-8, the function .decode open parentheses UTF-8 in strings close parentheses method, which is a method you can see in the code. Yeah, don't let my repetition of letters to take you astray. It's this line here, HTML page.read decode UTF-8. So this string, now stored in the HTML variable, represents the raw HTML source code of the web page. This step emphasizes the need to access and interpret the downloaded content as text, specifically HTML in this scenario. So like I told you in the beginning, we're gonna transform this web page into a string of markup. So so we can parse it, we can read it and get from it whatever we want. Alright, so you can repeat that, but let me just repeat the last part, this before the string. Since web pages are typically encoded in a specific character encoding, most commonly UTF-8, the decode UTF method is then used to convert these bytes into a Python string. This string, which is the Python string that we just converted, this string now stored in the HTML variable. You see, because we started the whole thing with the line that starts with the word HTML with the equal sign after it. This is the variable, and we called this variable HTML. So this is the point that I wanted to impress on you. So this step emphasizes the need to access and interpret the downloaded content as text. Because we're accessing a website on the internet, we're going to have to download it as text in order to manipulate it. So step 3, parsing the HTML structure, code. So this is the line after that. He's taking us back to an importing, because it's related to importing the BS4 from Beautiful Soup. So from BS4 import Beautiful Soup. and soup equal, now this is the line after the HTML line that we are reading. Soup is another variable, equal sign, then beautiful soup, the function, or calling the class from the library. Uh, Beautiful soup, open parentheses. Parameter 1 is HTML, parameter 2 is a string, HTML.parser, close parentheses. So what this does, this part introduces the Beautiful Soup library, a powerful tool for parsing HTML and XML documents. The code imports the Beautiful Soup class and then creates a Beautiful Soup object named soup, which our line starts with. So this object is the variable. Uh, this object takes two arguments, the HTML string HTML and parentheses and a parser HTML.parser. The parser is responsible for understanding the structure of the HTML and creating a parsed tree, which is a hierarchical representation of the HTML elements. This step is crucial for navigating and extracting specific data from the complex HTML structure in an organized and efficient way. Number 4, locating specific HTML elements. So our code does that, and specifically the part image 1, comma image 2. These are two variables also. Equals soup.find underscore all open parentheses img string close parentheses. So this is the function, a built-in function in Python, find all. It's just gonna find us the additional images in the website. Description: the soup object, this is the soup object, now provides methods for searching and navigating the parse tree. Okay, the parse tree, remember that. The find all open parentheses image method is used here to locate all the HTML tags which represent images, the img tags that is, within the parsed HTML. This method returns a list of all the img elements found. The code then attempts to unpack the first two elements of this list into the variables image1 and image2. This demonstrates the ability of a web scraper to target and isolate specific HTML elements based on their tags and attributes, the HTML tags that is. It's important to note that if the page has fewer than two img tags, this line would result in a value error. All right. Now the code comes to the point where it's going to access the element properties. So we're talking about the line print open parentheses image1.name and print open parentheses image2.name close parentheses. Once the img elements are located and stored in image1 and image2, the variables, these variables now hold beautiful soup tag objects which have been initialized from the Beautiful Soup class that we got from the library. These objects have attributes and methods that allow you to access information about the HTML element. The .name attribute, as used here, returns the tag name of the element. In this case, it would print img twice, assuming the findAll method found at least two img tags. This illustrates how a scraper can extract specific properties or attributes from the identified HTML elements. Then we move to navigating the HTML structure. The code is the print open parentheses soup.title.string close parentheses. This is the soup object that also allows you to navigate the HTML structure using the tag names as attributes. Here too, soup.title accesses the first title tag found in the HTML. The .string attribute then extracts the text content that is directly inside the title tag. This demonstrates how a scraper can traverse the hierarchical structure of the parsed HTML to reach and extract specific pieces of information based on the HTML element relationships. In this case, it's retrieving the title of the web page. In summary, this code highlights the following key steps and concepts in web scraping. Requesting, which is fetching the raw content of a web page using HTTP requests. Reading and decoding, which is accessing the downloaded content and converting it into a usable text format, HTML. Parsing, which is analyzing the HTML structure to create a navigable representation of the document. Then locating, which is identifying and isolating specific HTML elements based on their tags and attributes. And finally, accessing properties, which is extracting information associated with the located elements like tag names, attributes, or text content. And finally, navigating, traversing the parsed HTML tree to find related elements and extract data based on the document's structure. These are the fundamental building blocks for more complex web scraping tasks, which might involve handling multiple pages, dealing with different data formats, and storing the extracted information in a structured way. Now let's go back to a very important beginning of the code, which was the requests library. The requests library is used for making HTTP requests to a specific URL and returns the response. Python requests provide inbuilt functionalities for managing both the request and response. Python requests module has several built-in methods to make HTTP requests to specified URI using GET, POST, PUT, PATCH, or HEAD requests. An HTTP request is meant to either retrieve data from a specified URI or to push data to a server. It works as a request-response protocol between a client and a server. Here we'll be using the GET request. The GET method is used to retrieve information from the given server using a given URI, and it sends the encoded user information appended to the page request. Next, we have Beautiful Soup that we use in our code. So it provides a few simple methods and Pythonic phrases for guiding, searching, and changing a parse tree. A toolkit for studying a document and removing what you need. It doesn't take much code to document an application. This is all due to the parse tree, by the way. Beautiful Soup automatically converts incoming records to Unicode and outgoing forms to UTF-8. You don't have to think about encoding unless the document doesn't define an encoding. And Beautiful Soup can't catch one, which is a rare case in any modern system nowadays. Then you just have to choose the original encoding. Beautiful Soup sits on top of famous Python parsers like LXML and HTML, allowing us to try different parsing strategies or trade speed for flexibility. This is another detailed summary of the same code. You can review later, line by line. In the following 3 slides, you will find more details about the code, about each line, about functions, and about keywords in Python. So you can read them later, and we will be going through running the code right now. So what are the steps to run a Python script? First of all, we install the required libraries. So in our case, make sure we have the requests and Beautiful Soup both installed, and we install them by using the terminal command. If you're using bash or zish shells, no problem. The command is pip install requests Beautiful Soup 4. So you get both in one go. Next, we save the code in a .py file. So let's say it's called webscrape.py or whatever. And then we run it in the terminal or your editor. So the command is on the terminal python followed by the name of the file .py. So web underscore scrape.py or whatever the name is. Then we have to access the variables. So in our case, we have four variables. One is the response object, which contains the response details, including the status code and the content. Then we need the HTML content, um, which stores the raw HTML content of the web page. And after that, the beautiful soup object, which is the parsed HTML content, allowing you to extract specific elements. For example, extract the title of the web page or a certain word inside the web page. And then we have the pretty HTML soup.prettify, the function, which outputs just for formatted HTML to help understand the web page structure. This is because many HTML files out there have a lot of problems, so it's not all smooth sailing while parsing those. So now let's move to our next topic, which is parsing, because that could be one of the most important functions in this code. So why is parsing so important? This is because web pages are often filled with vast amounts of HTML markup, JavaScript, or CSS and CSS. Parsing helps the scraper navigate this structure to locate specific elements like text, images, or links that you want to extract. Now we do that with by tags, by a lot of depending on what element we want. So let's go through the steps and then we'll go through the elements. First step of parsing in a basic web scraping program is the retrieval of the HTML, naturally. So first your scraper fetches the raw HTML content using a tool like requests or URL lib. Then it loads the content for parsing. Then it navigates the parse tree. This is a very important part. The parse tree contains nodes for tags, attributes, and text. This is how we find what we want to find inside the HTML. The scraper uses methods like the built-in methods in Python like find all, select, to locate elements based on tags or CSS selectors. Then it is extracting the data. Once the target element is identified, the scraper pulls the desired data like text within a tag from the parse tree. So this is parsing in a nutshell. Uh, you gotta practice that because it's very important and practice makes perfect, as they say. And here you can see the execution of the code on the terminal, and it gives us the word Dionysus and the two images. They printed out the string text, the img. So all is well with this code. You can review everything. You can pause or rewind or go forward for if any of my words or accent are not clear, and You can ask for a one-to-one session. We can clarify everything and have more practice, and there will be a lot more lessons on the way. Thank you very much.